Alright, and here we go with solving systems of equations by substitution. With me, Mr. Hain. And our essential question for this video is, how does what I know about solving equations help me solve systems of equations by substitution? So here we go. Here's the thing. If you have two equations with two variables, you are graphing two lines if nothing is raised to an exponent. And so the solution, as we talked about in the solving systems by graphing video, is that where those two lines cross. And so when we do it by substitution, when we solve those systems by substitution, we use what we know about solving equations so that we can apply that to a system of equations. Let's dive right in. All right, so the first two examples are when the variable is already isolated. So let's take a look at A. So for A, I already see that one of the variables is isolated. The first equation says y equals 6x minus 11. And the second equation is negative 2x minus 3y equals negative 7. But you see in the first equation, it already says what y is equal to. So I can take the 6x minus 11 and I can substitute it directly into the second equation. As you see in the blue circle drawn down to the y in the second equation, nothing will change in the second equation except for the y. Because these two equations, we want to find out where they overlap, I can take, or where they intersect, I can use what y is equal to in the first equation and put it into y for the second equation. So remember, the first equation is 6x minus 11 equals y, and the second equation is negative 2x minus 3 times y. So now I'm going to multiply that second equation, and instead of the y, you see that I have negative 2x minus 3 times the quantity in parentheses 6x minus 11. That whole thing equals negative 7. So now I can use what I know about solving equations. I have a number outside of parentheses. I'm going to multiply. So negative 3 times 6 and negative 3 times negative 11 gives me negative 2x minus 18x plus 33 equals negative 7. So I've distributed the negative 3. Now I can have two x's on the same side, and so since they're on the same side, I just combine those two together. They're both negative, so same signs, add them up. I get negative 20 plus 33 is equal to negative 7. And now this goes all the way back to chapter 1 and solving two-step equations. Boom. Subtract the 33 from each side to isolate the variable, divide by the coefficient, which is negative 20, to isolate the variable, and now I've got x. X is equal to 2. If I subtract the 33 from each side, I have negative 20, x is equal to negative 40. Divide both sides by negative 20, x is equal to 2. Now what do? I'm not done. Remember, the solution to a system of equations is where those lines intersect. So I'm going to take that x equals 2 and put it back into the first equation. I have y equals 6 times x, but since I'm substituting it back in, it now says y equals 6 times 2 minus 11. In other words, I've kind of back substituted what x is back into the first equation. So 6 times 2 is 12, so y is equal to 12 minus 11, and I know that is 1. I have an x and I have a y. Those make a coordinate, x comma y. The solution to a system of equations is a coordinate point, and so that solution is 2, 1. Cool. So let's take a look at the second example and go a little bit deeper. And you'll see me write the answer for the second example as well. So for B, I also already have y is equal to negative 3x plus 5 as my first equation. And then I have 5x minus 4y equals negative 3 for my second equation. All right, cool. So that means I can substitute the y, the negative 3x plus 5, into the second equation. And so my second equation, instead of being negative 4 times y, is now negative 4 times the negative 3x plus 5 from the first equation. So the second equation, when I've substituted in the first, or what y is equal to, now says 5x minus 4, parentheses, negative 3x plus 5, close parentheses, equals negative 3. Okay, so now I just distribute the negative 4. So negative 4 times negative 3 is equal to positive 12, and negative 4 times positive 5 is equal to negative 20. All right, cool. So 5x plus 12x minus 20 equals negative 3. So I have two x's on the same side, so I combine those. So 5x plus 12x is 17x. So now I have 17x minus 20 equals negative 3. Two-step equation, isolate the variable. So I add 20 to each side. That gives me 17x is equal to 17. Kaboom. I know what x is equal to. And just like in example A, now that I know what x is equal to, I back substitute it into the first equation. So instead of saying negative 3x plus 5, I know that x is equal to 1. So here in the darker purple, you see I have y equals negative 3 times 1 plus 5. Cool. Negative 3 times 1 is negative 3. Negative 3 plus 5 is 2. The solution to a system of equations is a coordinate point. So my answer is 1, 2. All right. So in this video, I did not have extra examples because I have an accompanying notes page for students in my class. This allows you to complete numbers 1 through 3 really on the back of your notes page. It says 1 through 4 on the video, but it is actually 1 through 3. So go ahead and pause the video, leave these up as an example, and complete numbers 1 through 3 on the reverse side of your notes. Now, if you're not with me, just Google for system of equations by substitution. You'll find tons of work that actually should look something like some of these examples, but don't worry, there is more. Pause the video, complete those questions. I'll be here when you get back. All right, so we have another case for C and D, solving by substitution. And as it notes inside of the video, it says you need to isolate. So if you look at these equations, none of them have y equals. And I started with the hard one. Get excited. Let's get the hard stuff out of the way. For example, C. Two equations. First equation, negative 3x minus 4y equals 2. Second equation, 3x plus 3y equals negative 3. All right. None of them are solved for anything, but I do notice that in the second equation, all of the coefficients and the constant are divisible by 3. So I'm going to divide all of them by 3. And now I have x plus y equals negative 1. Wait a second. Now I can solve for y. Subtract x from each side, so now I have y is equal to negative x minus 1. Sweet. So now I'm going to take what y is equal to, and I'm going to substitute it into the first equation. So the first equation was negative 3x minus 4 times y equals 2. But now, solving the second equation for y, I have y equals negative x minus 1. So now the first equation, when I put that y value in, is negative 3x minus 4, open parentheses, negative x minus 1, close parentheses, equals 2. Sweet. So again, now I have a number outside of parentheses. So I'm actually just solving a multi-step equation. So what I know to solve for equations. Distribute that negative 4, so I get negative 3x plus 4x plus 4 equals 2. Combine like terms. So the negative 3x and the 4x, put them together. I got x plus 4 equals 2. I'm going to subtract 4 from each side. X is equal to negative 2. And again, now that I have the x value, I'm going to back substitute that in. And I'm going to substitute it into what I already solved, the y equals 4. So since x is equal to negative 2, y is equal to negative times negative 2 minus 1. Two negatives make it positive. 2 minus 1. Yes, and the answer to the system of equations is x comma y, so it's negative 2 comma 1. Beautiful. All right. It's a lot to take in, and I know it's a lot of steps, but really all we're doing is solving for a variable and then putting it into the second equation. Let's take a look at D. Negative 4x plus y equals 6. And negative 5x minus y equals 21. All right. So the first equation has a positive y all alone. So I have negative 4x plus y equals 6. So I'm going to add the 4x to each side to isolate y. Now I have y equals 4x plus 6. And I'm going to substitute that into the second equation. Now remember, I always put it in parentheses, and here is why. Negative 5x minus y equals 21 is my original equation, but it subtracts y. So I have what y is equal to, and so I put it in parentheses. So when I substitute it into the second equation, it says negative 5x minus, in parentheses, 4x plus 6 equals 21. And this is important because I can distribute the negative, and that changes the sign. So now I have negative 5x minus 4x minus 6 equals 21. Combine the like terms, so negative 5x and negative 4x turn into negative 9x minus 6 equals 21. Two-step equation. You got this, people. If you've been following along with me, you've got this. Inverse of subtraction is addition. So I add 6 to each side. Negative 9x is equal to 27. Divide by the coefficient of x, so I have x is equal to 27 divided by negative 9, or x is equal to negative 3. Awesome. And you see I've manipulated the equation, the first one, so it has y equals. Let's just use that. So instead of saying y equals 4 times x plus 6, I have y equals 4 times negative 3 plus 6. Of course, that's negative 12 plus 6, which is negative 6. And the answer to a system of equations is a coordinate point x, comma y. So, sorry for my cringy singing. Negative 3, comma, negative 6. Kaboom! We're done with example C and D. We had to isolate some of the variables, and you did it! This is about as tough as it gets for solving by substitution. If you're following along at home, go ahead and continue working on that set of problems that you Googled up, solving systems of equations by substitution. Or if you're in my class, this will help you solve numbers 4 through 8 on the back of your notes. I know it's mislabeled on my slides, but you can pick it up from the back. Go ahead and pause the video as you complete some of your work, and I've got some special cases to talk about when we get back. And we're back! So let's take a look at E and F. So for example E, I have negative 3x plus 3y equals 4 as the first equation. And the second equation is negative x plus y equals 3. All right. So by now you guys are practiced, and so you see that the second equation already has a y alone. So I'm going to add x to both sides. Boom. Isolate y at y is equal to x plus 3. Okay. So if I know what y is equal to, I can pop it into the first equation. So instead of saying negative 3x plus 3 times y, I have negative 3x plus 3 times, open parentheses, x plus 3, close parentheses, equals 4. All right, so let's distribute that 3. Kaboom. So now I have negative 3x plus 9 equals 4. What? Hold on. I see something weird. See, the 3x's, the negative 3x and the plus 3x, when I combine those terms, they cancel. What? I have no x. So now it says 9 equals 4. That's enough for the very rare triple question mark. Does 9 equal 4? If you said no, you're right. 9 does not equal 4. That means there's no solution. These lines are actually parallel lines. They're parallel lines with a different y-intercept. So that means the parallel lines, they never touch. So there's no solution to this system of equations because the system of equations is solved where they intersect. Parallel lines don't intersect. Unless maybe F. Let's take a look. So by now you see that the first equation, negative 5x minus y equals 7. And the second equation, 10x plus 2y equals negative 14. Wait a second. Okay, the first equation, add 5x to each side. That gives me negative y equals positive 5x plus 7. That negative means I can divide or multiply everything times negative 1. Or, if you prefer, change all the signs. So y is equal to negative 5x minus 7. All right. I have what y is equal to. I'm going to pop that into the second equation. So instead of 10x plus 2 times y equals negative 14, I've got 10x plus 2 times the quantity, open parentheses, negative 5x minus 7, close parentheses, equals negative 14. Distribute the 2, so I have 10x minus 14 equals negative 14. Wait a second. Yeah, if you're feeling uncomfortable, it's because you see that there's a 10x minus 10x, and we know that's equal 0. So they cancel. That leaves us with negative 14 is equal to negative 14. Does negative 14 equal negative 14? If you're saying yes, it's because you're right. They do equal, which means it's always true, which means there's infinite solutions. These are really just the same line. They're just overlapping each other. It's the same equation. I just multiplied the first equation by a positive 2, or a negative 2 rather. And that just cancels them out. They're really just the same equation, and they're overlapping lines, so it's infinite solutions. So that means you can solve the rest of your worksheet that you found on the internet. If you found a worksheet there, numbers 9 through 12 on the back of my notes. And yeah, spoiler alert, numbers 9, 10, 11, and 12 are either going to be no solution or infinite solutions. So that's a way to double check your work. And go ahead and pause the video. I'll be here when you get back. And that's it, guys. Write your summary if you're in my classes and make sure your table of contents is updated. But if you're not in my class or if you're following along at home, either way, until next time, keep doing the math.